I am Dr. W.B. Gulmade from Kamlanir Mahavidyalaya, Nagpur. Today we are going to discuss the last part, that is part number 6 of chemistry of polymer, that is introduction to polymer chemistry. And in this last part we are discussing what is the molecular mass of the polymer and degree of polymerization, and after that some examples of biodegradable polymers, that is PHBV, and also nylon 2, nylon 6, and different commercial applications of the polymer. And as we know that polymer consists of number of molecules or monomers, and therefore molecular mass of the polymer is the average of molecular masses of the constituent molecules, and therefore molecular formula or molecular mass of the polymer depends upon the degree of polymerization. And now what is the degree of polymerization? It is nothing but the number of monomer present in the polymer, that this is known as the degree of polymerization. So this degree of polymerization determines the molecular mass of the polymer. So number of monomers present in the polymer unit or polymer molecules, this number of monomer unit is known as the dP, that is degree of polymerization. So we are discussing all this part in today's presentation. So today's part is the part number 6 and introduction to polymer chemistry. And in this part we are discussing the topics are given here: molecular mass, what is degree of polymerization, what is meant by biodegradable polymers and their examples. Two examples are there, one is PHBV and second is the nylon 2, nylon 6, and some important commercially important polymers and their applications. So number of polymers are there and they have different application. So all this part we are discussing. And so first part is the molecular mass and degree of polymerization. As we know that what is the molecular mass of the polymer? Polymer is a macromolecules, that is high molecular weight or molecular mass compound. And there is a difference between macromolecules and the polymer. So there is a repeat unit present in the polymer. Macromolecule and polymer both are high molecular mass compound. So but the repeat unit is there in the polymer. So what is molecular mass? As we know, polymer also consists of different types of molecule and different types of monomer. So the molecular mass of polymer is the average of constituent molecules present in the polymer, and therefore, and also we know that this molecular mass of the polymer depends upon the dP, which is known as degree of polymerization. And this degree of polymerization is nothing but the monomer unit, that is number of monomer unit present in the polymer molecules. Now there are two types of polymers. One is a low molecular mass polymer and second is a high molecular mass polymer. So two types of polymers are there. One is low molecular mass polymers and second is high molecular mass polymers. And in case of low molecular mass, they have low mechanical strength. In case of high, they have high molecular mechanical strength. So the polymer possesses the molecular mass more than certain minimum value in order to exhibit the properties needed for their application. So different applications are there, and depending upon that they have different degree of polymerization. So which is also known as sometimes critical degree of polymerization. Polymerization process has controlled after a certain stage. It can be controlled after a certain stage. So polymer containing hydrogen bonding, the critical degree of polymerization is lower. So if there is a hydrogen bonding in the polymer, then the degree of polymerization is lower. So this is about the molecular mass and degree of polymerization. And now here this is the slide here shown. Some addition condensation polymer. So question is one here: classify the polymer as addition or condensation. As we know that here polyvinyl chloride, that is PVC, it is an addition because only one monomer is present and there is an addition. So only we have to identify whether these examples are addition or condensation polymers. So PVC is a addition polymers and polyamide is a condensation polymer because nylon 66 are the examples, and there is a two monomer and there is a loss of small molecule like water or ammonia, like that. So this is condensation polymer. Polystyrene, only styrene. Styrene is there, and then we get polystyrene. So monomer is a styrene, therefore it is addition polymer. And next is the polycarbonate. This is polycarbonate is a condensation polymer because it contains two monomer, and in case of polycarbonate two monomers are there. One is a bisphenol and second is the phosgene. So these two monomers are there, so it is condensation. And then no lock is a phenol formatted resin, and therefore there is a loss of water molecule, and again this no lock is a condensation polymerization of polymers. So you can classify these examples, for example, into addition and condensation. Another example is here they are given. Complete the following table. So here nylon 6, and in case of nylon 6, repeating unit is a E-caprolactam. As we know that we have seen the synthesis of nylon 6, and in case of nylon 6, repeat unit is a E-caprolactam, and therefore we have to write repeating unit. Repeating unit is also there, and name of the monomer E-caprolactam, repeating unit you have to write, and formula of the monomer also we have to write, and uses of that nylon 6. In case of nylon 66, repeating unit is there after polymerization, and name of the monomers in case of nylon 66 is one is adipic acid, second is hexamethylene diamine. So you have to write monomer here, and also write the formula of the monomers. So you can complete this table. Pteridine also you have to write the repeating unit. In case of pteridine, it is already we have seen pteridine or dacron, and in case of pteridine and dacron, the repeating unit is you have to write repeating unit, and after that what is the example, that is in case of pteridine, monomer is ethylene glycol and terephthalic acid. So two monomers are there, terephthalic acid and the ethylene glycol, and their uses already we have discussed. Melamine having a repeating unit only trigenine. Name of the monomer, that is only the melamine. There is melamine is a monomer, it is not a polymer. So this is melamine, only it contains trigenine. So formula of monomer, what is alternate carbon nitrogen is there, and therefore write the formula. Uses of melamine are there. It forms the polymer, melamine formatted polymers, which are very useful material. Now in case of degree of polymerization, one example is given here, that is the critical degree of polymerization is low for nylon 6 while it is high for polythene. So two examples are there, and degree of polymerization is low in case of nylon 6 and high in case of polythene. So how can we explain? Example is given here. Solution for this: in case of nylon 6, nylon 60 is a example of polyamide polymer. Amide linkage is there and has strong intermolecular hydrogen bonding. And already also we have seen pages of hydrogen bonding also affect the degree of polymerization. So nylon 6 is a polyamide polymer, and it has strong intermolecular hydrogen bonding. So there is a strong intermolecular hydrogen bonding. As we know, what is hydrogen bond? Hydrogen bond formed between hydrogen atom and most electronegative element. So in case of this nylon 6, there is a strong intermolecular hydrogen bonding present as an intermolecular forces. And on the other hand, if you see in case of polythene chain now has only weak van der Waals forces are there. So nylon 6 have strong hydrogen bonding, and in case of this polythene have weak van der Waals forces are present as intermolecular interactions, and therefore stronger intermolecular forces present in the compound, the critical degree of polymerization is lower for nylon 6. Therefore nylon 6 have lower critical, because of the forces, the critical degree of polymerization is lower. In case of nylon 6, critical degree of polymerization is lower as compared to the polyethylene. So this is the reason that depending upon the intermolecular forces. So strong hydrogen bondings are present in the nylon 6 and weak van der Waals forces are present in the second polythene, and therefore nylon 6 have lower critical degree of polymerization. And next slide shows biodegradable polymers. As we know, there are a number of examples of as we know that polymer waste are making any environmental pollutions. Nowadays there is a ban on the polymeric materials. So plastic materials. So now here scientists are now trying to solve this problem, and now they have synthesized artificially some biodegradable polymer. And two important biodegradable polymers are there. One is we can say two nylon to nylon 6, and in case of nylon to nylon 6, this is the polyamide copolymer of the amino acid, and therefore another example of biodegradable polymer is PHBV, is a copolymer of two biofunctional beta hydroxy carboxylic acid, and also here the beta hydroxy valeric acid. So this PHBV is a copolymer, and also nylon 2 nylon 6 is also a copolymer. So here these polymers are biodegradable. As we know that there are large number of applications, useful applications of the polymers are there, and nowadays as we know, polymers are very useful material in our daily life, and most of the household materials, window, doors, or table, chair are made by the plastic, and also in kitchenwares also they are made by the different articles are made by the plastic. But now there is a problem that there is a blame for that it creating the that is the environmental pollution, and because of this that is the certain new biodegradable synthetic polymers have been developed, and aliphatic polyester and polyamide with large which contain polar linkages are important classes of biodegradable polymer. So two important class of the biodegradable polymers are there. One is aliphatic polyester and second is polyamide. First is a aliphatic polymer, polyester and polyamide are the examples of biodegradable polymers. Some more example of these biodegradable polymers are is the as we know, dispose of natural waste attacked by soil microbes and get degraded to humus. But most of the synthetic polymers and plastics cannot be degraded by the microbes, and therefore they stay in the environment for a very long time and causes the pollution. So to overcome this problem, these two important polymers, that is one is a PHBV and second is nylon 2 nylon 6, these two biodegradable polymers have been synthesized by the scientists. So what is now PHBV? These two polymers are the biodegradable polymers, and now PHBV is the short name given, and PHBV is a copolymer of two bifunctional beta hydroxy carboxylic acid and beta hydroxy valeric acid. That is beta hydroxy carboxylic acid. Example is beta hydroxy butyric acid, that is the 3-hydroxy butanoic acid, and second is monomer is a beta hydroxy valeric acid और उसका दूसरा नाम है 3-hydroxy pentanoic acid. So these two compound or these two monomer undergo and forming this type of PHBV biodegradable polymer. Hydroxyl group present in the one of the monomer forms ester link by reacting with the carboxyl group of the other monomer. Therefore, PHBV is an aliphatic polyester. As we have seen, aliphatic and polyamide. Aliphatic polyester is an example of biodegradable polymer. So this compound PHBV is also aliphatic polyester, and with the name उसका नाम है poly beta hydroxy butyrate को beta hydroxy valerate. So short में उसको बोलते हैं PHBV, ये उसका नाम है, and PHBV is degraded by microbe in the environment. So this is biodegradable polymer. Reaction is shown here. Beta hydroxy butyric acid, ये है एक बीटा पोजीशन में हाइड्रोक्सी ग्रुप है, तो इसको बोलते हैं ये COH ग्रुप है. CO के बाजू में जो कार्बन होता है वो अल्फा, उसके बाजू में जो कार्बन होता है वो बीटा. अब बीटा पोजीशन पे क्या है OH, इसलिए उसका नाम है बीटा हाइड्रोक्सी ब्यूट्रिक एसिड, क्योंकि 4 कार्बन है, 1 2 3 4, तो ऐसे 4 मतलब ब्यूटेन का ब्यूट्रिक एसिड, और उसी तो बीटा पे क्या है OH, तो बीटा हाइड्रोक्सी ब्यूट्रिक एसिड. और सेकंड है बीटा हाइड्रोक्सी वैलेरिक एसिड। सो दिस हियर इज आल्सो नो, ये अल्फा है, ये बीटा है, तो बीटा हाइड्रोक्सी हो गया ये भी, और 1 2 3 4 5 है, तो उसका नाम है 3 हाइड्रोक्सी पेंटानोइक एसिड, उसका दूसरा नाम है। एक तो बीटा हाइड्रोक्सी वैलेरिक एसिड बोलते हैं उसको, 5 कार्बन है इसलिए, या फिर इसका आईयूपीएसी नेम है 3 हाइड्रोक्सी पेंटानोइक एसिड, 5 कार्बन है। तो इसमें से क्या होता है, ये वाटर निकल जाता है यहाँ से H और ये OH, सर ये वाटर, देयर इज अ लॉस ऑफ वाटर एंड फॉर्मिंग दिस टाइप ऑफ लॉन्ग चेन। तो यहाँ पे OH में से ये OH गया, वो बचा है CH2, यहाँ पे CH2, यहाँ से भी ये H2 निकल जाता है, फिर CO बचा, यहाँ पे O एक है, फिर CH2, इस टाइप से ये कंपाउंड PHBV फॉर्म हो जाता है। So there are two monomer which undergo polymerization and forming this type of biodegradable polymer. So this is the simple reaction given here of the formation of PHBV. Another important biodegradable polymer is the nylon to nylon 6. So nylon to nylon 6 is a polyamide copolymer. पहला example है aliphatic polyester is a biodegradable polymer. Second example है polyamide copolymer is also another example. उसका example है nylon to nylon 6. So nylon to nylon 6 is a polyamide copolymer of 2 amino acids. And 2 amino acid कौन से हैं इसमें, ग्लाइसिन और एक दूसरा है epsilon amino caproic acid. So glycine and amino caproic acid is an example of this type of biodegradable polymers. And after that now both these are the biodegradable polymers, and last part is left, that is some important polymers are there which have their number of application in different field. So here some commercial important polymers are shown. तो पहले कॉलम में दिया है ट्रेड नेम, सेकंड में दिया है मोनोमर, और उसका थर्ड कॉलम में दिया है पॉलीमर, उसका स्ट्रक्चर, पॉलीमर स्ट्रक्चर कैसा होता है और उसके एप्लीकेशंस क्या क्या होते हैं। तो पहला एग्जांपल है Perspex और एक्रिलिक ग्लास। तो एक्रिलिक ग्लास का इसमें मोनोमर होता है मिथिल मिथा एक्रिलेट, ये मोनोमर का ये स्ट्रक्चर भी है मिथिल मिथा एक्रिलेट, और सेकंड है पॉलीमर, उसका स्ट्रक्चर कैसा होता है। तो स्ट्रक्चर उसमें दिया है कि इस टाइप का स्ट्रक्चर होता है पॉलीमर का, और उसके एप्लीकेशंस है लेंस बनाने के लिए, पेंट इंडस्ट्री में, सिक्योरिटी बैरियर, LCD स्क्रीन के लिए, रेजिस्टेंट ग्लास भी है, शटर रेजिस्टेंट ग्लास। तो सेकंड है बुना यस, अपन ने देखा है बुना यन भी होता है, बुना यस और बुना यन रबर। तो इसमें मोनोमर है ब्यूटाडाइन है और दूसरा एक्रिलोनाइट्रिल है, ये ब्यूटाडाइन है और ये एक्रिलोनाइट्रिल का एग्जांपल है मोनोमर, और उसका पॉलीमराइजेशन इस टाइप से अपना चेन फॉर्म होता है और ये पॉलीमर चेन है। उसके बाद उसके एप्लीकेशंस हैं बुनायन के एडेसिव्स, रबर बैंड के लिए, शू सोल बनाने के लिए, और रिंग्स दैट इज एंड गैस्केट्स। सो अनदर एग्जांपल इज PVC, पॉलीविनाइल क्लोराइड। PVC इज इम्पोर्टेंट एंड पॉलीविनाइल विनाइल क्लोराइड है, ये मोनोमर है और ये उसका पॉलीमर होता है। तो विनाइल का पॉलीविनाइल फॉर्म हो जाता है पॉलीमर, जैसा इथिन का पॉलीथीन। तो यहाँ पे उसका यूज है वाटर पाइप्स बनाने के लिए, इसका यूज होता है रेन कोट बनाने के लिए, या फ्लोरिंग टाइल्स के लिए भी इसका यूज होता है। अनदर एग्जांपल इज पॉलीएक्रिलोअमाइड। सो इसमें मोनोमर है एक्रिलामाइड, तो एक्रिलामाइड का पॉलीमराइजेशन होता है। तो पॉलीएक्रिलामाइड ये मोनोमर है और इसका ये पॉलीमर है, और उसका यूज है पॉलीएक्रिलामाइड जेल इज यूज इन इलेक्ट्रोफोरेसिस। Some more examples are there of important polymers. यूरिया फॉर्मल्डिहाइड रेजिन, उसका अपन ने देखा एग्जांपल यूरिया फॉर्मल्डिहाइड, अपन ने 2 एग्जांपल देखा है रेजिन, एक है फिनॉल फॉर्मल्डिहाइड, दूसरा है मेलामाइन फॉर्मल्डिहाइड। ये यूरिया फॉर्मल्डिहाइड रेजिन इज आल्सो देयर, तो 2 मोनोमर होते हैं उसमें, यूरिया एक और दूसरा फॉर्मल्डिहाइड। तो इस टाइप से ये यूरिया का है और ये फॉर्मल्डिहाइड CH2। ऐसा ये यूरिया का फॉर्मूला पता है आपको NH2CO NH2, तो यहाँ से एक H जाता है, यहाँ से एक H, और फॉर्मल्डिहाइड होता है उसमें से ऑक्सीजन, तो वाटर देयर इज अ लॉस ऑफ वाटर एंड फॉर्मिंग दिस टाइप ऑफ रिपीट यूनिट। तो इस टाइप का पॉलीमर का ये स्ट्रक्चर है, और उसका यूज है यूरिया फॉर्मल्डिहाइड रेजिन का अनब्रेकेबल डिनर्स वेयर्स, डिनर सेट बना सकते हैं, डेकोरेटिव लैमिनेट्स बना सकते हैं। तो इसका बहुत सारा एप्लीकेशंस है। अनदर एग्जांपल इज ग्लिप्टर। ग्लिप्टर में 2 मोनोमर्स हैं, एक है इथिलीन ग्लाइकॉल और सेकंड है थैलिक एसिड, और इसका ये स्ट्रक्चर है पॉलीमर का, और ये उसका यूज होता है पेंट इंडस्ट्री या पेंट बनाने के लिए, और लेकर्स वार्निशेस भी बना सकते हैं। और अनदर एग्जांपल इज पॉलीकार्बोनेट। तो पॉलीकार्बोनेट में दो मोनोमर्स है, एक है बिस्फिनॉल, सेकंड है फॉस्जीन, और ये उसका पॉलीमर का स्ट्रक्चर है बिस्फिनॉल और फॉस्जीन। ये इस टाइप से कंपाउंड फॉर्म होता है। उसके एप्लीकेशन है इलेक्ट्रिकल फील्ड में, टेलीकम्युनिकेशन हार्डवेयर में, फूड ग्रेड प्लास्टिक कंटेनर बनाने के लिए। और उसके बाद में लास्ट एग्जांपल दिया है थर्मोकॉल। इट इज़ वेरी इंपॉर्टेंट मटेरियल मेड फ्रॉम एयर filled thin wall bits of this polystyrene। तो ये जैसा स्टाइरिन है तो ये थर्मोकॉल होता है, ये पॉलीस्टाइरिन स्टाइरिन है, ये उसका पॉलीस्टाइरिन का एग्जांपल है और नॉन बायोडिग्रेडेबल है। ये स्टाइरिन कैन लीच व्हेन हीटेड, देयरफॉर इट इज बैन। तो इसको थोड़ा बैन किया है बिकॉज इट इज लीच व्हेन हीटेड, अगर हीट होता है तो उसको मतलब ये इसको बैन किया है। तो इस टाइप से ये कुछ कॉमर्शियली इंपॉर्टेंट पॉलीमर्स है and their application and their what are the monomers and their applications are given in this table. So today here we have completed this chapter of introduction of polymer chemistry, and in this part we have seen what are the different types of polymer, classification of polymer on the basis of different properties and different sources, and after that we have seen some important compounds of the polymer and their applications we have seen. So this is an important chapter. In this we have seen different aspect about the polymer chemistry.